In this video, we're going to solve quadratic inequalities in one variable, and we're going to solve them algebraically. So a quadratic inequality in one variable can be written in one of the following forms, where a, b, and c are real numbers, and a does not equal 0. So ax squared plus bx plus c can be less than 0, it can be greater than 0, it can be less than or equal to 0, or greater than and equal to 0. So let's take a look at our first example. We have x squared minus 3x minus 4 is less than 0. So we're going to solve for this quadratic inequality. So we'll go ahead and set it equal to 0 to solve. We're really solving for our x-intercepts. So we can go ahead and solve, and we can solve by factoring in this case. So we can factor it to x minus 4 and x plus 1. And so setting each piece equal to 0 using the zero product property, then we can solve for our intercepts. We know that x is 4 and x is negative 1. So we can go ahead and represent that on this number line. So x is 4. And we do that with an open circle. We do it with an open circle because it says less than. If it said less than or equal to, then we would put it as a closed circle, meaning we could include that value. So this is also an open circle at negative 1. Now what we're going to do is we're going to test each interval to see when we plug in a value for x, if that value will work and make this true. So for example, we would want to test, let's go ahead and test 0. That's always a quick one to test. We can plug in 0 to see when we plug it in, will it be less than 0? You have a choice of either plugging it in to here before you factor, or if you want, you can plug it into the value in the factored form. So we plug it into the factored form, we get 0 minus 4, 0 plus 1, is that less than 0? So we have negative 4 times positive 1, and that is in fact less than 0. So that means it's true, and so we can go ahead and shade in that area. Anything that is in this area between negative 1 and 4, it will make this inequality true. So let's go ahead and try a number to the other side of, let's see, on the other side of 4, greater than 4. So let's plug in 5. We have 5 minus 4 times 5 plus 1 is that less than 0. You could kind of tell already that when you have 5 minus 4, that's going to be positive, and 5 plus 1 is also positive. That means when you multiply them together, it will be greater than 0 and won't work, right? So some of you can see that right away, and that's perfect. So we see that the answer would be 6, and it's not less than 0, so you would not shade in there. It is not true. Then you go ahead and test in the other interval as well. So we can test negative 2. Negative 2 minus 4 times negative 2 plus 1 is that less than 0. So we get negative 6 times negative 1, and that becomes a positive 6. Therefore, it is not true in this area as well. So the answer to this inequality are the answers here when x is between negative 1 and 4. So you can go ahead and write it in this way. X is between negative 1 and 4, and that's what makes this inequality true. Now, if we look at graphically, so if we were to graph x squared minus 3x minus 4, and that's a parabola, I think that'll also help you see why is this area true. So when you look at the graph, I already graphed it for us, then we look at when is it true that the parabola is below the x-axis, and so when it's less than 0, so you see that it is true in this area here. Okay, so for all of these, what you want to do is go ahead and practice solving algebraically in order to find the solution. Now that solution, we want to include this number line. We want to show the test for each area, as well as writing what the answer is here. So go ahead and try number 5 and number 6. So try these out. These are the solutions. So you find with 2x squared plus 3x minus 2, your x-intercepts are x is a half and negative 2, and there are closed circles there because it says equal to. Then you test in each area. The only one that works is between negative 2 and a half. So I wrote it in two different notations. One in our set notation, x is between -2.5, and then also our interval notation, -2 to 1/2, and those are brackets. Number 6, the solutions would be the outside. So in this case, it would be when x is less than -1.55 and x is greater than 0.215. And the other notation, an interval notation, is here, just in case you want to take a look at it. Thanks for watching, and I hope this helps.